This is the circuit board of a Megmeet outdoor mini-split air conditioner, and in the previous video, I talked about its filtering section. Now, I will explain how its SMPS circuit works and provide all the relevant information. So what happens here is that when the voltages come in, they are converted into 320 volts. After the conversion to 320 DC volts, you can see this capacitor is placed here. Now this side is the neutral side, and the other side is the positive side. Looking at the positive side, we have two resistors placed here, R113 and R130, both of which are 1 ohm resistors. These are installed purely for protection, so that if, for any reason, high voltage or high current comes in, the resistors will burn out. The purpose of installing two resistors is that if excessive current or voltage comes in, the first resistor will burn quickly, preventing the current or voltage from crossing over. After that, the second resistor is placed so that when the second resistor burns out, the voltage does not damage the chopper or the rest of the system. However, if both resistors burn out, then it becomes inevitable that the chopper will burn as well. After that, there is a switching IC installed, TNY288DG, which is an SMD type. This IC can handle very high voltages, up to 600 volts. The purpose of this switching IC is to turn the entire system on. To keep the switching IC running, a system works in the background called feedback. If it doesn't receive feedback, this switching IC will only work for a few nanoseconds and then stop, preventing the system from staying on. Now, let me explain where the feedback voltages come from. As soon as the switching IC gets electricity, it turns on, and an internal timer within the IC activates. The internal timer operates continuously to control the switching cycles. At the beginning of each cycle, the IC checks the feedback signal. Let me show you where these feedback voltages come from. Here, you can see an optocoupler installed. If for some reason there is fluctuation or damage in the optocoupler, the switching IC won't work. The system will either turn on for a few seconds and then shut off, or it will keep trying to turn on. The switching cycle turns off, but the oscillator timer continues to work internally. So you need to check this optocoupler because the feedback for the switching IC comes through it. You need to inspect the entire circuit and the optocoupler itself, as it is prone to failure. Since there are high voltages across its collector and emitter, it has a higher chance of malfunctioning, so it is important to test it properly. After that, even if the entire system here is fine and everything is working correctly, if there is still a problem, I will tell you where to check for overvoltages. Now, look here. When the voltages are generated at diode number 19 on its positive side, you should get 18 volt DC. If you're not getting 18 volt DC here, then there is an issue with the chopper, and the chopper could be damaged, possibly due to a faulty winding, which would then need to be repaired. Now, I will show you from the back side. Looking at the back side, you can see the EC2 capacitor. On pin number 1, you should check the positive and negative terminals, where you should get 12 volts. Then, on the third pin, you should get 3.5 volts, which is going to the regulator, and I will show you from the other side. After that, check the negative terminal, and on the positive side, you should get 15 volts. If 15 volts is present here, I will also show you where it's coming from. Apart from that, at EC number 16, you should get 18 volts as well. So when you have 18 volts, 3 volts, and 12 volts coming from the chopper, it means there might be an issue in the system. Now what could be the issue? I will show you. When the 18 volts comes in, look here, there is a 15 volts voltage regulator installed. The 18 volt comes to its input pin, which is on this side, and the output pin is on this side. If 18 volts is reaching this point, and if you check the back side, the center pin is ground. You can check here or on the back side, it's the same thing. So when you place the ground here, you should be getting 18 volts. If it's slightly higher, it's not a problem. The output here should be 15 volts. If you are getting 15 volts, it means the system up to this point is perfectly fine. After that, you need to check the voltage regulator. This is a fixed 3.3 volts regulator, so you should get 3.5 volts or 4 volts at this pin and the ground, but no more than that. If the voltage exceeds this, the voltage regulator will heat up and the system will keep tripping. So you should have 3.5 volts or 4 volts here, and then between the ground and this pin, you should get a 3.3 volts output. If the correct voltages are present, the system will work perfectly fine and operate smoothly. Next, if the diodes installed here are either open or short-circuited, the primary voltages won't be generated. Without the primary voltages, generating the secondary voltages will also become difficult. That's why these need to be checked carefully. There are filtering capacitors connected with all of these voltages: 12 volts, 3.5 volts or 4 volts, 18 volts, and 15 volts. If these capacitors become short-circuited or open, the system won't function properly or won't work at all. These components also need to be checked. This is how the SMPS, switched mode power supply system works, keeping the entire system on. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.